What up, everybody? Welcome to Garage Math with Mr. H. This is my garage, and I am Mr. H, Mr. Henriksen. I had a different name for this site, but evidently there's a lot of people out there building math skills, and there's a lot of Mr. H's, so not many Mr. H's in a garage. All right, here's what we're gonna do today. We are gonna solve inequalities, but what I wanna do is kill two birds with one stone, which is a really dumb saying because I don't think you should kill any birds. Now, unless they're angry. These look the same, but here's what I want to show you. When we solve this one-step equation, what thou doest to one side, thou must doest to the other, we're going to do the exact same thing here because that's an inequality, not an equal sign. Okay, so here's what I'm going to show you. When you solve equations, I wish I had a weight bar. I wish I could. Oh! All right, imagine I'm doing tricep dips? No, tricep curls. And what I want to do is take weight off. So if I have a weight bar and there's like 40 pounds on each side, and I want to go a little bit lighter, and I take 5 pounds off of this side, what do I have to do to this side? I also have to take 5 pounds. Otherwise, it's going to be like this, okay? So when I do my curls, and I usually curl about 250, 260, when you add weight to one side of the bar, you have to add the exact same weight to the other side of the bar. That's how you keep your bar balanced. And that's how you keep your equations and inequalities balanced. Okay. So we have to get this x by itself. Reminds me of middle school. Okay, we have to get rid of this -5. The way we undo a -5 plus 5. Yes, I want you to write it exactly the way I have it. -5 plus 5 becomes 0. See ya. X is all by itself, and -3 plus 5 is 2. Now, here's what we're going to do. Some really mean teachers or thorough teachers may ask you to check this. And what you're going to do is you're going to plug 2 in here. You're going to go to the side. You're going to write CH, put a colon, 2 minus. Here's what we're going to do. I'm not going to make you do that, only if you promise to mentally check it. Okay, so x equals 2. So let's plug it in right here. 2 minus 5. 2 minus 5. What's 2 minus 5? 2 minus 5 is -3. -3 is -3. That means we get a smiley face and a puppy clap. Okay, well, that looks so much more difficult because it has the alligator mouth. It doesn't matter. The alligator mouth just comes down just like the equal sign does. And solve it the same way. Obviously, plus 5, x is greater than 2. Now, here's how we're going to check this. Pick any number in the whole wide world that's greater than 2. And we're going to plug it into the inequality, and it's going to make it true. So let's pick a really easy number like 7.32. Don't pick that number. Let's pick 3, because 3 is greater than 2. 3 minus 5 is -2. Is -2 greater than -3? It is. Now, want to see something that you could do the other way? Pick a number that's not greater than 2, and that will make this false. A number that's not greater than 2 that I'm good with in my head is 0. 0 is not greater than 2. Okay, 0 minus 5. 0 minus 5 is -5. Is -5 greater than -3? No. Never mind. Okay. So that's the answer. When you are solving one-step inequalities, solve it exactly like you would an equation. Okay. Sometimes people get confused. They go -15, and I say, why'd you go -15? Why'd you go -15? And they say, well, because you always get rid of the number on the left side. And I say, says who? And they say, well, normally that's how it is because the x and the number is usually on the left side. And I say, that's actually normally true, but that's not the rule. The rule is get the variable all by itself. Okay, so we have to get the x by itself. We have a +4. What makes positive 4 disappear? Basically, we want to make it 0. Minus 4, that's 11, equals x. Now, my world and most of the math writing world always puts the variable to the left side. You might just want to get into the habit of doing it. Now, before we puffy cloud it, what do we have to do? Check it. Okay, x equals 11, x equals 11. 11 plus 4 is 15. Yep. One-step equation is exactly the same as a one-step inequality, because check this out. 15 is greater than x plus 4. It's the exact same problem, okay? So we bring that guy down, minus 4, draw your line. Now, this is the tricky part, however. When we learned how to graph this in yesterday's video, we wanted to put the variable on the left side. Now, when you flip-flop this, it doesn't matter, because if you flip-flop an equal sign, it's still going to look like an equal sign, okay? So what we're going to do is put the x on the left side, but if you flip this stuff, you also have to flip the inequality. Now, before I circled it, I'm back. We want to plug at least one value in to see if it makes sense. So what number is less than 11? How about 10? 10 is less than 11. 10 is less than 11. 11 plus 4 is 15. Uh-oh, 15 is greater than 15. That's not true. So if x is less than 11, x is 10. 10 plus 4 is 15. 15 is greater than 15. That's not true. I made a mistake here somewhere. Minus 4, 11. 11 is greater than x. X is less than 11. If x is 10, 10 is less than 11. That should make this true. 11 plus 4 is 15. 15 is not greater than 15. It's 10, not 11. 10 plus 4 is 14. Whew, I almost had to start over, but that would have been weird because I would have had to rewrite all this. If x is 10, 10 plus 4 is 14, 15 is greater than 14. If you guys could just erase that last 40 seconds, I'd appreciate it. Okay, now let's go quick. Okay, get the variable by itself. The variable's on this side, a minus 10, plus 10, plus 10, plus 10, plus 10. Now, I know we have some funky decimals. Either plug that into your calculator, just put the negative 4.5 plus 10, or use it at your head, or show some work. I'm going to happen to say that that's 5.5. 5.5 equals A, okay? A equals 5.5. Now, we got to check it. 5.5 minus 10 is negative 4.5. I hope so. If that's not right, whatever. Okay, no, it is right. Ooh, this was the answer to the extra credit problem that I did on the other video, but I never gave you the answer at the end of the video, and I know some of you were probably like, I knew the extra credit answer, because we had less than, greater than, less than or equal than, greater than or equal than, but the fifth one is not equal to. That's also an inequality. Okay, so we're going to solve it the same way. Okay, we're going to go plus 10. We're going to go plus 10. So now we have 5.5 is not equal to A. 5.5 is not equal to A. So this one's kind of cool. Any number not equal to 5.5 makes this true. The only number that doesn't make it true is 5.5. That kind of went over your head. Hit pause and watch it 17 more times. All right. Oh, I'm not going to make it under 10 minutes, am I? Okay. Here we go. We're going to go quickly. So if you hit pause, maybe I can talk faster and I can get this under 10 minutes, but I don't think we're going to make it under 10 minutes. All right. If the temperature goes up 6 degrees, it will be hotter than 100 degrees. So here's what we're going to do for these two problems. We are going to take these word problems. I don't like word problems. Get over it. And then we are going to write an inequality. We might even graph them, because why not? So if the temperature goes up 6 degrees, it will be hotter than 100 degrees. Okay, if the temperature goes up. So we need to write an inequality, a one-step inequality to make this true. Okay, so hotter than kind of seems like greater than. Greater than 100 degrees. If the temperature goes up, what math operation symbol is up? Boink! x plus 6. Now, what you always want to do when you do these problems, anytime you do a variable problem for the rest of your algebraic life, you always have to establish what the variable is. So for this problem, you should always write it somewhere. Sometimes they give it to you. X equals the temperature you started with. X is the temperature. Okay, if it goes up 6, it's going to be greater than 100. Can it be 100? No, greater than 100. And then we go minus 6, draw your line. X is greater than 94 degrees. I think that was a boy band at some point. 94 degrees? Bye. I don't know. It seems familiar, but I don't think that was right. Okay, now, Yoda. Yoda. There is a big Yoda behind you. He's on the wall. Yoda is going to make lightsabers, and he's going to give them away as gifts. Who wouldn't want a lightsaber? I don't even know how you practice with a lightsaber. Imagine like a Nick, you would just miss arms and fingers, and if it just touches you, I think that would be a tough class to train for. They must have some sort of non-actual like lit up lightsabers, like wood swords or whatever. Yoda is going to make lightsabers, and he's going to give them away as gifts. He's giving them away. He's giving away 3. I would really like one of these. I do have the one from, I should find it. The one from Disneyland. My kids made them, but now I own them both. But needs to have at least 3 to fight the dark side. So he makes them, and he's going to give away 3. Give away. What operation you think give away is? Give away. Now, I bet you it's minus. So, like, he's going to give away 3. Okay? And then he must have at least. Is it less than, greater than, less than, or equal to, greater than? He has to have at least 8 left over. Can he have 8 left over? Yes. Can he have 9? Yes. Can he have 7? No. At least. He must have at least 8. Okay? So that's the inequality. And X, I want everybody right now to write on your paper, what does X stand for in this problem? X stands for how many lightsabers he needs to make. He's going to give away 3, and he has to have at least 8 left over. Okay? Plus 3. Now, if I had more room, I'd write lightsabers. If he makes 11 and he gives away 3, does he have at least 8 left? The answer is yes. He has exactly 8 left. Let's pick a number more than 11. Let's pick 100. Can he make 100 and give away 3 and still have at least 8 left? Yes. Now, what about a number less than 11? What if he doesn't make any? Then he can't give any away. That doesn't make sense. Of course he can't make. He has to make at least 11. Okay, that's how we write inequalities. We're going to do multiplying and dividing tomorrow. It's a little bit trickier because you're going to have to flip it. But for now, good job with this. I'll see you later. Let me get my little button, and peace.